Hello, here's the long-awaited 7.2, which is on multiplying and dividing rational expressions. So let's get to it. I've got the weird angle trying to avoid how messy everything has gotten. It's so crazy here. Okay, so 7.2, multiplication and division with polynomials. And this actually can be done in any order. They tell us how to multiply. They say multiply the numerators and multiply the denominators and factor all the pieces and reduce the pieces that are exactly the same. These reduce to 1. The reason I say that is like if you had 2/3 and you were going to multiply that by, let's say, 6/7, then you could, if you wanted to, you could multiply these together and get 12. Multiply these together and get 21. Then you could factor the pieces. 12 is 2 times 2 times 3 over 21 is 3 times 7. And then 3 divided by 3 would give 1, right? And then that would leave 4/7. So that would be a way of doing it. You multiply the numerators together, multiply the denominators together first, and certainly that would work. The other way that it would work, and this is, I guess, what I prefer to do, your choice though, is I prefer to tell myself 6, and I don't usually write it, I usually think it. 6 is 2 times 3 over 7. So the 3 reduces with the 3. 3 divided by 3 is 1. And I'm left with, now multiply the numerators. 4, this is a 1, right? 4 times 1 is 4/7. Either way, you get the same answer. Okay, so that's just me. This is the directions I guess the book gave, so I guess I put those same directions, and I was just telling you that this doesn't matter when you know, on that. So your choice. But it does answer the question, can something in the top reduce with, divide out with something directly in the bottom? Yes. Can something in the top do it with a corner? See how that's kind of catty corner? And the answer is yes, because you could write them all over one numerator and one denominator. So they're asking me to multiply here, and what I would do, and I want to show factoring the pieces. So I want to write 8 as 2 times 2 times 2. That's 8, right? 2 times 2 is 4 times 2 is 8. I don't know why those two 2's got so close together. X times x times x. Over 7y to the 4th times 14, 2 times 7 times y to the 6th. And so this is with monomials. And so factoring monomials is a little silly. And so if you're saying 16, I was going to write that as 2 times 8, which is 2 times 2 times 2 times 2 xx, right? Okay, so anything will reduce in the top and the bottom. So here are 3 2's, and they'll reduce with these 3 2's right here. And when you reduce them, you get 1. And here are 3 x's, but there are only 2 x's in the bottom, so 2 of them will reduce with these 2 and give 1. So when I reduce them out, divide them out. And then this x doesn't have anybody to reduce with. This 2 can reduce with this 2. So divide them out. Anything in the top with the bottom. So this x didn't have anybody. And then the 7 with the 7, reduce it. And 4 of those y's with 4 of those y's can reduce out, leaving 1, right, when you reduce. So what's left over in the bottom? In the bottom is nothing, right? 1 is down in the bottom. And in the numerator, I got x, y squared. So you can do it that way. That's the factoring method. You can also use the method that they taught you in chapter 4. And so if you like. And you can also, because they're monomials, you could use the shortcut method of saying, well, 8 and 16 have 2 in that 8 goes into 16 2 times, and so you could do that. And then x to the third, that's 3 x's, and that would reduce with two x's and leave one x up top. So you can start reducing that way if you liked as well. And then you would have, here you have a 2, and the 2 would reduce with the 14 and leave a 7, and the 7 would reduce with the 7. So certainly it would all work, right? And you would get exactly the same answer, however you do it. Okay, so then this one, I'm going to do it the same way. I'm going to make this divide into a multiply, so I want to rewrite this divide as a multiply. So when you rewrite it as a multiply, you have to flip the next fraction. So as I go along here, I'm going to have 6x to the second, 5y to the third, times 11z to the second, over 2x to the second, times 10y to the eighth, over 33z to the fifth. And 6 is 2 times 3, times x, and 5y, times z, and 2xx. 10 is 2 times 5, y, 8 of them. Those are my times between my y's. You don't really need them, but I'm wanting to make sure that you know that, hey, those are separated. 3 times 11, z, 5 of them. And then when I go reducing, anything that's in the top, and of course, as I've said, you don't have to write this out. You can think this, or you can use the quotient rule on a monomial. So since I have a monomial over a monomial, there's a different way that I could go, but this is the idea of how you would do it if it was a binomial or a trinomial. And so you have to factor with those. So the 2 reduces with the 2. I'm just going to circle it. So there's 2 and the 2. And the 3 and the 3. When you divide them out, you get 1. X's, there's 2 of them here, and I thought I saw 2 of them in the bottom, and I did. So these reduce out, leave 1. Whether I write the 1 or just tell myself there's a 1 there is okay. The 11, so I'm now reducing. This is the new part, right? The reducing is the new part. The z's, and the 2 doesn't have any 1. The 5 reduces out. 3 of the y's, leaves 1 in all these spots, right, when I reduce them out. And what do I have left? I have some z's, but I don't have any more z's in the top. So I have, in the numerator, I have 2. Here's this 2. And I have 1, 2, 3, 4, 5 y's, y to the fifth, over z to the third. What's wrong, Susie? What's wrong, Susie, girl? You know you've been fed, sweetie. Okay, so now number 16. This is a binomial, and the only way that you can reduce it is to factor all the pieces and then have things that are exactly the same. So the monomial 2 reduced with a monomial 2, and the monomial 3 reduced with a monomial 3. But this is not a monomial, it's a binomial, and it will only reduce with a y minus 1, a binomial y minus 1 that's in the denominator, and I don't have one. But I do notice that both things in the denominator will factor, right? So y minus 1 won't factor, so I'm just going to write this here, y minus 1. And I like to put parentheses around it to show myself that I knew that I should factor it, but it wouldn't factor. And then factor in any order you want. You're going to have to factor this, 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 and this, just like I factored all of these pieces, right? And I prime factored on them. And so I'm going to factor off here to the side so I don't muck up my work. Y squared minus y minus 6. And you could factor this in your head. I'm writing down what most people would just think, right? So this is what people would think, oh, it's a trinomial. It doesn't have a greatest common factor other than 1. And so it's y times y. And it could be 3 times 2. And that would be good because when I subtract them, I get 1. And in fact, I want the 3 to be negative. So this would be y minus 3 times y plus 2. And I'm going to put that, this is replacing, this is that denominator. So I'm going to put its factored form right here, y minus 3 times y plus 2. Times. And so this was my think, right? I factored that. Now I have to factor this piece. And if you can factor it in your head, I think if you've been practicing your factoring, you probably can factor it in your head, right? You could say to yourself, well, I know that to make, there's no greatest common factor other than 1, and to make 6 could be 2 times 3, and that adds to 5. So, and they're same signs, so this is y plus 2, y plus 3. So that's what I mean by, I think I could factor that in my, definitely in my head, if I've been practicing my factoring. And then, and you can use your diamond couple if you like, or your AC factorization, but make sure you show your work if you do one of those methods, right? And then, so that people know what you got going. This is a difference of squares, right? So it's what squared minus what squared, and this is y and this is 1. So this is y plus 1, y minus 1. And then now I factored it. Whether you write it together all in one numerator or not, it doesn't matter. This y minus 1 and this y minus 1 are binomials that are exactly the same, and they will reduce out and be 1. And this y plus 2 and that y plus 2, one in the top, one in the bottom, when you divide them out, you get 1. And then there's nothing that will reduce with a y plus 3, right? This is a y minus 3. That's different than a y plus 3. And there's nothing that will reduce with this y plus 1 in the numerator. So my answer in the numerator has a y plus 3. And the parentheses, you can write them, or you don't have to write them. You can leave them off, and the book will leave them off. And then the denominator is y minus 3 and times y plus 1. And you could FOIL that together, but it's not necessary to FOIL that together. And so there would be your answer. And then you're all done. So this one, someone's been kind of sweet to us on 63. It may not look like they've been sweet to us, but they've been a little bit sweet to us because they factored this. This is all in factored form, so that's great. And it's times this fraction here. And this kind of looks a little big compared to that, but this is over 1. Everything's over 1. So this is y minus 3. I don't need to factor it. It's already factored. So I certainly don't want to multiply it together because the form that's helpful is to have it factored. So this is over 1 times, and then this is negative 1. And then this is right here not factored, so I don't know why they didn't factor that for me. That would have been nice, but that's a difference of squares. That's my friend, the difference of squares. And so I'm thinking what squared minus what squared so that I can get it factored, and this is y and this is 3. So I'm going to put the result of my factoring. It's the same thing, it's just in a different form, right? Y plus 3, y minus 3. Then the y plus 3's would reduce out and make 1, and the y minus 3's would reduce out and make 1. And then I only have, everything's out of the denominator. I have 1 in the denominator, so you don't have to write it when you have 1 in your denominator. And my numerator, I have y minus 4 and the monomial negative 1. So you usually would write your monomial first, negative 1 times y minus 4. Now in the back of the book, I bet you they have it, instead of writing negative 1, I bet they write negative times y minus 4. And that would be okay as well. And by the way, it would be okay to distribute the negative and have negative y plus 4. All of these are good answers. It doesn't matter which one you have of those. They're all wonderful answers. You did a lovely job on that. And then there are 2 more problems to do over here. And these problems are, because of the factoring you have to do, they're wow, is what they are. And so this one is a division, and so I want to rewrite this as a multiplication. And so when I rewrite it as a multiplication, I have to flip this. So this is going to be 4t squared minus 1 over 6t squared plus t minus 2 times 27t to the third plus 8 over 8t to the third plus 1. And I have to factor all four of these. So this is a binomial, and this is a trinomial, and that's a binomial, and that's a binomial. And I kind of like to factor my binomials first, and I like to factor out, so I don't know. I would probably factor these three and then factor that, but that's just me. So I notice that this one right here, when I start off with it, I notice that this one, and I'm just thinking about it, is a difference of squares, DOS. And it is what squared minus what squared. So it's 2t and 1. So I'm going to put the factored form of it right here. So I'm going to have 2t plus 1, 2t minus 1. And then right here, this is a cube, is what it is. So I'm going to have to whip out my cube formula. So I'm thinking, what to the third plus what to the third? And so this is 3t and 2. So right here is going to go finger over 3's, write what you see, is going to go 3t plus 2, square. So I'm going to take the 3t and square it, that's 9t squared. And then I'm going to multiply those together, that's 6t. So I'm using my cube factoring strategy. And I'm going to square that, and that's 4. And the signs go SOAP. Same as you started with, opposite, so that's minus, and always positive. Once you've used the cube formula, you're all done factoring. So this didn't factor any further. I didn't say that, but it doesn't. This I used the cube formula, so it's not going to factor any further. That trinomial is not going to factor any further. So now I'm thinking about this, and I'm going to get it factored as well. And I'm noticing it's a binomial, and it is a cube. So it's what cubed plus what cubed. And this is 2t, and this is 1. So song, right? Finger over 3's, write what you see. So this is 2t plus 1. It doesn't matter what order you factor them in. So if there's 4 of them to factor in any order you want. So this is 4t squared. Multiply them together. So square, multiply, square. So this is 2t. And then square. 1 squared is 1. Same as I started with. So opposite, always positive. Then I have this guy to factor here. So I'm going to factor him over here. Right? And I'm thinking, well, it's a trinomial and it doesn't have a greatest common factor. So it could be 2t times 3t. It might also be 1t times 6t. And it could be 1 times 2. And so I'm trying to think, what would it be? What would it be? And well, if it's going to reduce, you notice that none of these things have a 6t. You guys notice that? No binomial has 6t in it. So I think I'll try 2t, 3t, because they do like for things to reduce. So might as well give it a try. And let's see here. The signs are 1 positive, 1 negative. I don't know which one's which yet. So I know that the 2 can't come in here because I said the greatest common factor was 1. And if I didn't say the greatest common factor is 1, it is 1. And so I can't put the 2 in there. So it must be that the 2 goes over here and the 1 goes over here. And I can see that, oh, that's going to make 4t. And this is going to make 3t. And when I subtract them, because that's a minus sign, 4t, take away 3t, is 1t. So that's perfect. I need this to be positive. So this needs to be positive. And I need this to be negative so that I get positive t. So this is negative. So I got this factored here now. So this one was the one that I worked the hardest on, right? And so this was, you know, it was good that I showed my work there. I won't even say that's my thoughts, but, you know, I'm getting that factored. The rest of these were formula factoring. So once I recognized the base, I was just ready to write them down. So this is 2t. So I'm like writing all over the paper, right? 3t plus 2. And then here's the fun part, is that things that are exactly the same in the numerator will reduce out with things that are exactly the same in the denominator. And it doesn't matter which fraction they're in, because truly you can push it together and have it all be one fraction. You could say this times this and then say just like that, and now it's one fraction. So now they're all something in the top and something in the bottom. So 2t plus 1 with the 2t plus 1, 2t minus 1 with the 2t minus 1, and 3t plus 2 with the 3t plus 2. And these trinomials won't reduce with one another, and they won't factor. They're not exactly the same. So that's our answer. 9t squared minus 6t plus 4 over 4t squared minus 2t plus 1. I went on a walk, and I got a little too close to a rosemary bush. I don't know if you've ever done that before. And I brushed up against the rosemary bush, and now I smell like rosemary. So I have to get this stuff factored. And so I'm going to make my spot right here times, and I'm going to put 1 here, and I'm going to put 1 here. So here's going to be the numerator here and there. And factor it in any order you want. It doesn't matter. So if you say to yourself, well, I'm going to get those 4-term things right out of the way and factor them, when you factor this, you're going to put the result right there. And so for me, 4 terms are not something that I can factor without showing any work. And so if I try to do it, I'll get confused. And so I know that math apps can do it without showing any work, but most humans can't, one that's grouping. So I'm factoring this one right here. And it doesn't have a greatest common factor for all 4 terms. So I'm going to group the first 2, which has x squared in common. So this is x plus 2. And then I'm going to pull out the minus, and the common factor is 9. So minus 9 comes out here. And then if these are the same, then I can continue, and they are, so that's good. So I can continue. So this is x plus 2. It's the common factor, and I get x squared minus 9. This is all done, but this is, my friend, the difference of squares. And I just factored that same difference of squares on this page over here. I was telling people today that if I had a nickel for every time that I factored x squared minus 9, there it is, y squared minus 9, or x squared minus 9, same thing. I said I would be rich, 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 and here I am factoring it again. So it's x plus 3, x minus 3. So this thing factors as x plus 2, x plus 3, x minus 3. Okay, so that's my work for the numerator. And I'm going to put the result right up here in the numerator. So this is this numerator, and I'm going to put the result, how I factored it, right up here. So it wouldn't cancel before, but now that I broke it down into 3 binomials, thought I was giving myself plenty of room, but gosh, I write so darn big. It's this thick pencil, but I'm not going to complain because someone I love got me this thick pencil because I said I was breaking my leads, and so I'm not breaking the lead anymore, so that's one good thing. Okay, now I'm going to factor this one because I said that I was going to factor the worst things first, which to me, the 4-term things are the worst things. You can think that the trinomials are worse if you want. It doesn't matter to me. It doesn't matter what order you factor them in. You're going to factor them all independent of one another. So this does have a greatest common factor of x for all of the pieces. And so you factor out the common factor, and then after you get the common factor factored out, then you could ignore it. Okay? Not for good. It's part of my answer. So here it is there on my answer line, right? I'm not ignoring it forever. And so now I'm just now using, on this is 4 terms, so I'm going to use grouping, and it shouldn't have a common factor. So I have x squared, this is x plus 3, bring down the sign, plus, and then they have 4 in common. Uh-oh, This is going to be 4 times x minus 3. So I know right now that there's a boo-boo somewhere. So let me see what the boo-boo could be. So do you see the boo-boo that I made? I see the boo-boo that I made. And so when these are not the same, I know there's a mistake somewhere. And so I was looking back to see, well, where did I make my mistake? So I'm going to erase back to it, because I know that can't be right. And when I was multiplying with my eye, I saw where I made my mistake, and I had a sign error. And so this was really x to the third, this was right, plus 3x to the second, and then this was a minus 4x minus 12. And so this is, I made a sign error right there. This is where I made my sign error. And now I can group, right? I have my x already down here. So x squared, x plus 3, and the minus comes out, and 4. And so then this is x plus 3, because a negative 4 times a positive 3 is a negative 12. So they have x plus 3 in common. They have to be the same, and they are. So I have x plus 3 times x squared minus 4. So just like the x plus 3 is done. So I'm kind of having my answer line, and it's going out here. But so the x was done, and I ignored it, but I put it down here. The x plus 3 is done, and now I'm going to ignore it and put it on my answer line. But this is a difference of squares, right? It's what squared minus what squared. And in fact, I think I factored that one just a few minutes ago as well. X plus 2, x minus 2. And so this now is all done, right? And so this is my work for the second one. And it was a wow, right? I don't think I had any that hard to factor so far. Well, not hard, just a lot of steps, right? I had to keep going, and I'm looking at what I factored this to be, and I'm putting, so this is this and this are equivalent. And by writing it this way in this factored form, I'll be able to reduce an x plus 3 with an x plus 3, right? But I'm not there yet. So this guy right here is my third thing to factor. So I'm going to factor this trinomial, and I notice that it has a common factor of x. So x squared plus 5x plus, that was 6x, right? I miscopied it, but I was going good. Okay, and then this is x times x. This is not 1 and 6, because that makes 7. This is 2 and 3. Both are positive, x plus 2, x plus 3, and don't forget the x. And so that factored pretty nicely. It's going to go right here. X times x plus 2 times x plus 3. And then here, so I'm done with this. And the last one to factor is x squared minus x minus 6, which doesn't have a common factor. So I make the first work. It's a trinomial. 1 times 6, no. 1 and 6, that doesn't subtract to be 1. That subtracts to be 5. 2 and 3, that does subtract to be 1. So this is x, let's see, it's got to be a minus 3 and a plus 2, right? So x plus 2, x minus 3. And so that's how that one factored. That was the easiest one to factor. I'm glad I did it last, because I was getting pretty tired. And then now, so that's the old part. That's what we did in the previous chapter to this chapter. This is chapter 7, chapter 6, chapter 5. We learned to factor, right? And so we just factored 4 things. And now here's the new thing, which is that in order to multiply this together, you could write this as 1. You could times this, all the numerators together if you liked, and then you can reduce, right? A monomial x will reduce with a monomial x, and so these reduce out with one another. They're the same size, monomial, and they're both x's. They have to be the same size and exactly the same, so that when you divide them, you get 1. X plus 2 divides with an x plus 2 right here. and gives 1. X plus 3 with an x plus 3 gives 1. X minus 3 with an x minus 3 gives 1. X minus 2, there's no x minus 2 up there, but there is x plus 2 and x plus 2, and there's no x plus 3 in the bottom now. So in the numerator, my answer has an x plus 3, right? That's all that's left, and an x minus 2 in the denominator, and that's it. People love to cancel, so people will say to me, can't those x's cancel? And the answer is no, they cannot. And it's because they're not monomials, they're binomials. And so x plus 3 would only reduce, that's the binomial x plus 3, with another x plus 3. If you did it with numbers, you would totally see that, because remember x, it represents a number, right? If you did it with numbers, you would totally see that, oh no, it wouldn't reduce always. X can be any number. And so I just want to show you that you wouldn't even be tempted. So this is a bonus. This is a bonus look at. And so if I had, let's say that x was 4. 4 plus 3 over 4 minus 2. And so can those 4's cancel? And no. Order of operations would be to add the 4 and the 3 together, which is 7. Now, I can't add x and 3 together, right? That's as simple as it gets. But when I make it into a number, just so that you can see that the 4's don't cancel, and then I get 2 here. And see how I'm not going to be able to divide out a 4? 4 doesn't go into 7. And so that's why that you cannot cancel those x's, because it represents a number. And so it would have to reduce for every single number, and it can't be, because the first step would not be to divide the x's. The first step would be to add the x and the 3, which they're not like terms, and then subtract the x and the 2. Anyway, so just so that you can see with some, because people love canceling, so fun. I love to cancel myself. Okay, so we did a lovely job on those problems. So that's 7.2. How do I turn it off? Stop.